Hi everyone. This question has been taken from Fundamental Equation of Dynamics, Irodov question number 62. The question says a small body was launched up an inclined plane set at an angle alpha is equal to 15 degree against the horizontal. So find the coefficient of friction if the time of the ascent of the body is 2 times less than the time of its descent. So let us solve this question. So this alpha, the inclined plane inclination is 15 degree, which is given. So we have shown it here in this diagram. The small body we have magnified and showing it like this has been launched from point B, okay, and up along the inclined plane with a initial velocity u. So this body reaches to u and stops. Why? Because gravitational force, component of gravitational force and the friction force which is acting against the motion of the object. So this is retarding it. So therefore the object has to stop after reaching a certain distance. That distance is s. So v is equal to 0 and it reaches at, so when it reaches at u. So notations we have given like TBU, time taken from B, time taken for reaching the object, the small object from B to U is TBU, and time taken to reach from U to B is equal to TUB. So what is happening in this case? The object was launched from here with a velocity U. It stops here, but it will not remain there because the forces, the gravitational component of gravitation force will pull it down, will start pulling it down. So once it starts pulling it down, so it has to come down. Okay. So in the question it is given that TBU is equal to N times TUB. For solving, so let us say that mass is M, K is the coefficient of friction, N, capital N is the normal reaction force, and small f is the friction force. Okay, the body is launched up the inclined plane. Okay, so there is no motion in the direction perpendicular to the inclined plane because the body is all the time touching the inclined plane and going up. Component of gravitational force in this direction perpendicular to the inclined plane is mg cos alpha. N is the normal reaction force from the surface of the inclined plane to the small body is perpendicular in this direction. So N minus mg cos alpha, there is no acceleration in this direction, there is no motion in perpendicular to the inclined plane, so acceleration in this direction is 0. So we will write equation like this. So N is your m into g into cos alpha, and we know that friction force is the coefficient of friction into the normal reaction force. So this is so this equation we got as k into m g cos alpha. Now we will apply the NLM, Newton's law of motion, when the object is moving in along the inclined plane. So along the inclined plane, which all forces are acting on object is, one is the component of gravitational force in this direction, and since the body is moving in this direction, so friction force will be opposite to it. So this direction F will be acting. So mg sine alpha plus F is equal to m into A, right? So mg sine alpha plus, if we write we will put the value of f from here. So k into mg cos alpha m into s. Upon solving, we will be getting a is equal to g sin alpha plus k into g cos alpha. So this is, let's say this is question number 1. Object is stopping at u. Starting initial velocity was u, small u, and object has stopped at capital U point where its velocity becomes 0. So we will write the equation of motion for this. And the time is from TBU. Okay. So V is equal to U minus A into time of ascent, or U minus A into TBU. So we are writing TBU is U by A upon solving. So this is number 2 equation. One more equations we will write. V square is equal to U square minus 2A into S, the small s. So U square is equal to 2A into S. So this is equation number 3. Now we will consider the motion when the object starts sliding down, because it will not remain here. Why? Because gravitational component of gravitational force will pull it down. So we will make another diagram, and this is your another diagram. What is happening in this case? Object is moving in this direction. The friction force will be acting opposite to it. This is F. N will all remain the same, mg cos alpha, because this direction there is no motion. And along the plane downward side, mg sin alpha will be the component of gravitational force. So we will again write the Newton's law of motion. You can see from here. AD, we are taking the acceleration while coming down. So this is why we have written AD for easy understanding. AD is equal to g sin alpha minus kg cos alpha. So this is the equation we got. Okay, another equation, we will be using VD into V plus AD into TUB. Initial V was 0, so we have put 0. So TUB is equal to VD by AD. Now VD square minus V square will be 2 into AD into S. So this we have utilized, and we got equation number 6. And initially, as we discussed, N into TUB is equal to TBU. And let's say this equation A. So we should put all TUB, value of TUB, TBU from equation 5 and 6, and also the value of AD, A we can put from the equation 1, 2, 3, 4, 5, 6. So you have to take the help of 1, 2, 3, 4, 5 and 6 and putting the value of TUB, TBU, AD and A from those equations. So you will, upon solving, you will be getting K is equal to n square minus 1 divided by n square plus 1 into tan alpha. So this will be your answer. So when you put the value of n and alpha, you'll be getting K as 0.16. So hopefully this answer is clear to you, and there's no doubt in understanding. At any point or at any stage during the process of solving or in the write-up you have the doubt, so you can just comment in the comment box. I will explain that point again. Thank you.